I'm going to repeat everything I just said because I had it paused. So one more time, we're taking the concentrate, Roman numeral 2 %, concentration quiz. Takes 6 or 7 minutes to do that. That's in the concentrate on this part 2 module. Our test is in 2 days. This is just practice. That's all right. So one more time, if it says to add, do it. If it does not say to add, don't do it. Oh man, that one I lost by 4,000 points. Okay, let's look for just one more. Whew, we got 100% on one of them. That's fantastic. This is our next lowest one. Oh, that's just great. Don't even worry about that. I didn't clip the whole question. Hold on. Okay, what is the percent concentration M over V of a solution of 30 grams of sugar in 200 milliliters of water? Ooh, this one's typed incorrect, but it's fine. How many of you got this one and you added? Okay, well, this one will be worded better on the test. So this one, it's grams per volume. So you are given 30 grams. Your volume is 200 milliliters. This should say solution. That's why I wondered if anyone made that mistake. I can't do it. Anytime I shave, I inhale those type of masks. But then the next 3 days, I have this Velcro on my face that keeps the mask in place. There we go. All right, times 100, and that will equal 15%. Yes, sir.
When do you add the liquid?
If this was a liquid, like if this said milliliters of sugar and milliliters of water, you would have to add.
You have to add it?
Yep. But since it's different units, you won't add. So you got that. Okay, overall, I'm okay with it. You'll have 5 of these questions on your test. You'll have to get 4 out of 5 to get the perfect score, which most kids can. Like it's not the tricky one. The molarity is. All right, so make sure you are on page 15 and 16. I don't know, wherever parts per million is and dilution. While you're turning there, let me go get a visual aid I believe Colomore has real fast. So parts per million and dilution. I'll be right back. How are those grades looking, Lydia? Good. All right. So this thing right here, we'll use this to talk about parts per million here in a second. It has a million little beads in it. Wow, literally, I had 3 people looking at me right there. That's kind of sad. We'll talk about it in a bit. Okay, page 15 and 16, parts per million. Now, parts per million, like percent concentration, has nothing to do with molarity or moles or molar mass, and it has nothing to do with percent concentrations. Hold on. All right. So it is yet again another way to measure and report concentration. It is completely independent of the other two. All right, so here we go. Parts per million is a concentration expression that relates milligrams of solute to kilograms of solution. All right, so in the little fraction here, we have milligrams of solute over kilogram of solution. Now, that is literally all we have to do. We take the milligrams, divide them by the kilograms, and that gives me parts per million. Parts per million is a measurement we use when we report things that are really a really low concentration, like arsenic in the water. There's arsenic in all tap water that you drink, but it better be like 0.0001 or something like that, parts per million. Because arsenic is toxic and it will kill you. So these are really, really small amounts, but even if they're, like if that was a 2, it could kill us. So it's important even though it's almost really 0. All right. The only hard part of this is if I don't give it to you in milligrams and kilograms, you have to convert. And I know you hate it, but that's okay. So if we look at number 1, it says calculate the concentration of a solution in parts per million where 33.4 milligrams of naphthalene are mixed with benzene to make 1.5 kilogram of solution. If it gives you kilogram and milligram, you're ready to roll. So it's 33.4 divided by 1.5. Anybody have that for me?
22.3.
What's that?
22.3.
22.3 parts per million. We can call it part per million because it turns out there are 1 million, did I count right? Right there. Milligrams in 1 kilogram. So that's how we can get parts per million just by dividing mg over kg. Okay, number 2. Calculate the concentration of a solution when 145 milligrams of naphthalene are mixed with benzene to make 500 grams of solution. So here's the tricky part. I need to go from grams to kilograms, which is the same as going from milliliters to liters. So I end up moving it 3 places. In this chemistry class, we will always move it 3 places. The only question is which direction. If you are going from a gram to a kilogram, the number has to get smaller. If you're going from a kilogram to a gram, the number has to get bigger. So I take 145 and I divide it by 0.550 and I get 62 point what? 262? We'll just call that good. Whoops, not milligrams, ppm. All right, number 3. We have to go both ways. Calculate the concentration of a solution when we have 2.3 grams of naphthalene. So we have to make that milligrams. So that becomes 2300, because I go 3 places that way. That's my milligrams. And my kilograms, I go 3 the other way, 2.55 kilograms. and 901.9, 902. Does that sound about right? Okay. So parts per million. You've got to make sure you have milligrams on top and kilograms on bottom, and then you just divide. Now, there is a slightly different way if you are interested. This is only if you are interested. If you have a problem like number 3, where they are both grams, you can just divide them. 2.3 over 2550. But you need to multiply this answer by 1,000,000. And you should get the same answer. So if you don't like converting, then if they're both in grams, just divide and multiply them by 1,000,000. And that will tell you your parts per million. Go ahead. Yep. All right. Parts per million. It's on the exam. It will tell you it's parts per million, and you are looking for a milligram and a kilogram. The homework practice, it has a little bit of application as well as math. So let's turn here. The very back cover of the lab book. We're getting close to running out of paper. That's a good sign. All right. So first off, and these are common on like ACT tests, so that's why we practice these. We give you a table of data, and you have to do some calculations and then use the table. So the table is showing the contaminant level in ppm of these different things. So in water, we have this contamination. In air, we have these contaminants. So first off, in 59, a 25 kilogram sample of water is tested for arsenic and found to contain 5.1 milligrams. Will you set that up and then show your partner how you set that up? Just the math part. 59. Sometimes math is weird when I put the numbers in a different order than I did in the practice ones. Okay, so turn that on because some of the calculators don't work in the dark. So I take my kilograms and I put it as my denominator. I take my milligrams and I put it on the top. And you're going to end up with 0.2 something ppm. Okay, now there's an additional question to this. It says, does this level fall within the allowable limits in the table above? So we look at water, that's these. It's arsenic. Arsenic cannot be above 0.05. So would this water be safe to drink? No, not even remotely safe. Arsenic is very toxic. So there's 2 parts to both of these. 60 actually has 3 parts. We'll talk through that. All right, a car is tested for tailpipe emissions. Man, remember when those were a thing? Actually, you wouldn't, but I do. A 8 kilogram sample of the exhaust was collected. Now we're going to do 2 separate math, but they both have the same denominator. We're doing it twice because it gives you 2 different contaminants. Okay, so one is for carbon monoxide, which is CO, and it tells me 8.5 grams, but I need milligrams, so I multiply this by 1,000, or I move the decimal 3 places. So I have 8,500 milligrams per 8 kilograms. Okay, so that's carbon monoxide. Then the second question, it says 298 milligrams, that's pretty nice, of unburned hydrocarbons. How many parts per million for each? So I'll put the equal sign down here. I don't know why I never put an 8. There's supposed to be an 8 right there. Okay, so type these both in and then look at the table and tell your partner, did this car pass its emissions test? This time we're looking at air over here. All right, so 8,500 divided by 8 is what answer?
1062.5.
All right, 298 over 8 is
37 instead of 4.
all right. Now we look at the table. Remember, this is for carbon monoxide. The car is allowed to have 9. Did it pass emissions? No, this is a killer right here. This is what's his face? Gavin Barber's 50-year-old car. There's no way it would pass emissions, but it looks good. All right, the unburned hydrocarbons, it doesn't matter, it fails, but it fails there as well, correct? So most likely, if this was a real car, it would be a really old car that wasn't like made when we cared about emissions. And so that would be anything before 1980. Who cared? As long as it had muscle and looked good, that's why we bought it. But now we have regulations. All right, so the answer for both of those is that it would fail. Okay, now let me give you a practice problem that's like one on the test. It says, and I'm just going to scribble, it says the average human has 5 part per million arsenic in their fat tissue. Then it says the average human has 2 kilograms of fat tissue. All right, so it wants to know how many milligrams of arsenic do we have? Okay, so it's slightly different, correct? It gives you the ppm and it gives you the kilograms and asks for the milligrams. I'm very confident in your algebra skills. Just make sure you read the question correctly. So it says the answer is what? I went too high. 5, right? It tells me my denominator is 2 kilograms. So I just need to solve for x. How do I do that? Tell your partner. Times both sides by 2, and we would say, all right, well, the average person has 10 milligrams of arsenic. No, it's higher than that. But this is like exactly on the test. But that's, I don't know, that's what we have. If it's in our fat tissue, it's really not as bad. The worst part, and this sounds dumb, but if a lion ate me, it would ingest my fat tissue, break it down, and it would release the arsenic. Does that make any sense? So like when you go shoot a duck and you have your lead shot, it doesn't matter to the duck. You just shot it and it's dead. Why does it matter? It matters if you don't find the duck and then a bird eats it and then they ingest the lead and then it gets into the bloodstream and goes to the brain and it'll kill it. That's the #1 killer of predatory birds, is like unnatural killer, is lead shot. So if you're out there shooting, I highly encourage you. I don't even know, anyone duck hunters, can you still buy lead shot? You can? Well, don't. It's cheaper, but you should buy the other kind. Because unless you're like the most perfect duck hunter of all time, and you make sure and get every single bird that you've shot, you've introduced lead into the environment in a pretty unhealthy way. Anyway, so like I said, if the lion ate me, it would absorb that arsenic and it would be rough. I mean, I'm pretty much cheetah speed, so I'm not too worried. All right, that is parts per million. Let's talk now about our final piece of math, and it is called dilutions. All right. Murdoch said he was sick of math. This is the last math for a while. Are you okay with that?
Yes.
Okay. But David likes it and doesn't like matching terms. In a week, we have like the longest matching terms ever created by a science teacher. Now, it's nothing compared to Gerlach, so don't even at me. And Williams, I mean, I've seen those stacks. They're like 20 inches tall. But here we go. A useful laboratory technique is to make concentrated solutions and dilute them. I don't know, what does it say? Oh, I nailed that actually. And then dilute them with water to make less concentrated solutions than you need. All right. What does this have to do with anything? Well, a useful technique is to buy orange juice in a frozen concentrate can. Is that still a thing? All right. And then you store that in your freezer and then you dump it in and you add 3 cans of water and now you've diluted the concentrate. Easy enough. So we've done this. We're just confusing you with chemistry words. The more concentrated solution is called a stock, S-T-O-C-K solution. So in my storeroom, the one I don't let you go in, I have all sorts of highly concentrated stuff that I don't let you use. I water it down for 2 reasons: to save me money and to save lawsuits. Because the acid I let you use is 1 molar. The acid I store is 12. And it's not just 12 times more concentrated, it's 11 zeros more concentrated. So there's no way I would let you guys use it because it could very quickly damage your skin. Oh, I forgot about my parts per million. How could I have done that? Okay, sorry. This thing, before Nate Wheatley dropped it and we had to sweep everything off the floor, it had 1,000,000 things in here. Now it has like 1,000,010 things because it's got that hairball, it's got that fingernail, it has pencil shavings. Anyway, it's kind of not very cool. It's gross inside, but inside here are 1,000,000 things, give or take a few, and there's 1 black bead. One of them is black. So if you can imagine 1 single one of these dots being black, that's kind of the same idea as parts per million. And I'll put this over on the table. You can look at it, but please do not drop it. Then we have to sweep everything up, get as much of the hair and fingernails out, and then we have to refine the black bead, which is kind of a pain in the butt. Anyway, moving back to this. So, stock solution, that's the concentrated one. That would be the orange juice right here. And then we would water it down, and that is the dilute. To make a solution by dilution, you use the following equations. This looks tricky, but it's really not that bad. It says the volume of the concentration, the concentrated one, times the concentration of the concentrated one is equal to the volume of the dilute times the concentration of the dilute. Now, we can get away with this because when I water down my original orange juice, the same amount of orange juice is there. It's just spread over a bigger volume, right? But it did not change the total amount of the concentrate. All right, now I'm going to rewrite this equation as the following. Whoops, I meant that button. I'm going to say A times B equals C times D. Now, have a short discussion. I'll give you a minute, you and your partner. Tell me, well, tell each other, if I had to solve for B, what math would I do? Tell your partner. 1 minute of pure math talk. Ready, go. Oh, oh, oh. How we doing? Did you know what to do? Maybe, I don't know. Young, you know what to do? You missing your lab partner? Yeah. Yes. She's online right now. Want to say hi?
Hey, Logan.
There we go. Uh-oh, it's gonna be loud. That was the shortest minute of conversation I've ever heard in my life. Anyone willing to volunteer their lab partner to explain how you would do this? Lucy, thanks for volunteering your partner. Although that's Travis, we'll let Pugsley do it since that's where you're pointing. All right, Pugs, go.
You first need to figure out what C times D is, and then you divide it by A.
All right, here we go. Genius Pugs says, first we multiply C times D. Thumbs up if you agree with that. Good, because that's the right answer. And then you divide by A. Thumbs up if you agree with that. Really not that bad. Are we okay with that? It's 4 variables and you'll always know 3. You multiply these 2 and you divide by the other one. Okay, I have a little saying for that. You multiply the pair and you divide by the loner. So remember we had A, B, C, D. Pugsley says you multiply the pair and you divide that answer by the loner because we were solving for B. Fair enough? Okay, in a dilution, we will always do that same math. We will multiply the pair. Now, by the pair, I'm going to put the word of. Of is my connector. I multiply the 2 that are connected by the word of because they're the pair, and then I'll divide that answer by the 3rd number. So look at number 1 right here. What volume of water should be added to 10.19 milliliters of 8 molar acetic acid in order to obtain the final solution of 1.5? Tell your partner what 2 numbers are connected by the word of. Oh man, everyone partied too late last night, didn't you? It's all silence. We have 10.19 times 8. Who said that to your partner in at least mental telepathy? Okay, that's my pair. I turn the of into a multiply, and then I divide this by the one that's not there. 1.5, and I get what number? Anybody have that? Mike and my man? Okay, 54 point what? Now, what is my answer in? Truth is, on your test, it doesn't matter, but looking here, it says what volume, so my answer would be milliliters. Okay. Number 2. Go ahead, Lucy. No, you don't need to know. Like it says it. You could look, it doesn't say it overtly, but you look at 8 versus 1.5. So this is the concentrated one. That's going to be the non-concentrated one. Go ahead. No, thank goodness now. This one, but you do have to be careful. You don't have to convert milliliters to liters unless the problem gives you 2 volumes and 2 different units. And that would be a pain in the butt. So this one, find your pair. The pair are always pretty much located by each other as well. Multiply, divide. Do we have answers there? My good friend Sydney's just waiting for the calculations. Good setup. Anyone type it in? Pearson? Can I get an agreement to that number? I trust him. Okay, fine. It says volume again, so that'd be milliliters. It will not always ask for volume. It might ask for what concentration. We can do the same math. All right, are we ready? I didn't like that look, Megan. What?
I got 0.34.
Oh, I trusted Pearson and he stabbed me in the back.
I mean, I might have.
Yeah, I got 0.0.
Okay, okay.
I might subtract from the decimal, but I actually didn't.
Oh, really? Yeah.
0.034. Well, what am I doing? That's 8.75. Everyone type it in one more time and let's see what we get. 0.034. Who agrees? That's a lot of hands. Now, I should be careful. Since this was liters, the unit will be liters for this one. It just needs to match whatever that volume is. Okay. Should we turn to the back page? Wrap this puppy up. Put a bow on it. Okay. If you will look, let's see if there's any that are screwed up. Milliliters, milliliters, milliliters. Okay, look at 65 real quick. Just take a time out and look at 65. 65 is a tricky one. It's don't oh great me. It's not that bad. The problem is it gives you one volume in milliliters and one in liters. So you have to convert one. I would just say that's 0.75 liters. Doesn't matter which one, they just have to be the same. Okay, I feel like you can do these without my help. Let's take, well, we get out of here in a few minutes. You can get all of them done pretty quick if you have a real calculator. All right. So let me, you keep going, but just kind of listen. The plan for tomorrow is to review all of them, specifically the molarity, moles, and grams, because that was a week ago. That's the review plan tomorrow. Then Thursday, we'll take a test. It's 100% math. So you need a calculator that day. You are not allowed to use your phone on the exam as a calculator. So I do have plenty in here. It does benefit you if you usually bring your own one.